In this video, I will talk about threads and concurrency in Java, but using a specific set of classes and libraries that are in the java.util.concurrent, right there. Okay, these are executor services. So here's how it works. We'll exemplify it with this program. So let's say I have a class. In this case, it's called ZooInfo. It can be anything. The name is not relevant. With a main method. As we've seen in other videos about threads, when I start this main method, that is my main thread or the thread of the program. And I can span other processes into other threads. So, for example, this main method is really simple. It prints begin and end. But here's the thing. I want to span another thread. We've seen, I have a couple more videos on how to span threads from the main thread and with the thread class. We're going to now use something called ExecutorServices, which allow a little more flexibility, and they're easier to manipulate than a regular thread using the thread class. In order to create one of these executor services, we need to declare it. So I'm going to declare an executor service called service, and it's going to be null. Now, whenever we want to use an executor service, okay, it is important to notice that when we use the service, okay, no matter what happens with the service, with the thread, at the end, we need to shut it down or it will never shut down. So basically what we need to do is sort of like a try and catch, right? But maybe there's no exception. But we have to do something that's a finally, something that will get done no matter what. So in order to ensure that we always shut down the service, we need to wrap everything that we do in the service between a try and finally block. So no catch, finally. So it'll try to do something in the block, and once it's completed, it will proceed to the finally. And if for whatever reason it is not complete in the try, it'll still execute the finally block. Let's see how that works. So I'm going to create the try, and then in this service, it's not going to be null anymore. I'm gonna call the executor's class, and I'm going to call the new single thread executor method. What this does is it gives me a single thread executor service object, and that will be stored in service. Okay, a new single thread executor service. And this, when an object gives you different objects depending on the method that you call, that's called a factory pattern. So executors has a factory pattern, and service will be whatever thread executor service I call within that executor. So here my service is going to be a single thread executor, meaning an object that is able to execute one thread at a time, right? And we'll see how we work. But first we need to do the finally block here. So we're going to do something with the service. Once that's done, if the service is not null, meaning we did something with it, and actually right there it's not null already. So if the service is not null, meaning we're doing stuff with it, then shut it down. At the end of everything, shut it down. All right. Now, let's use this. When I want to assign a task to be executed in parallel with the main thread, right? I will do it like this: service.execute. And then in here, inside the execute method, the parameter that it receives is any object of type runnable or this lambda expression, a lambda expression with the task that I want to execute. More on lambda expressions is in a couple of other videos. So here, the only task this executor service will execute is just printing zoo inventory, just a print line. But after that's done, I want to execute something else. So I will add service.execute, right? And then in the lambda expression, I have a couple of instructions. So basically count to 3 for int I equals 0 to 3, print done. right? I++, and then print done. So basically this counts to 3 and then prints done. And then I'm going to add yet another thread, right? Service execute. This is another thread that's going to print zoo inventory as well. So what this program will do is it will start the main thread, and then, which says begin, and also says end. And as soon as the main thread starts, I'm going to start a separate thread that's going to execute in order these tasks. This one, and then this one. Okay? And these three are going to be executed in parallel while begin and end are executed while the main thread is being executed. So let's run this and see what happens here. So we will execute this. And we see here it printed begin, which was part of the main thread. Then, if we look at it here, then it did the service.execute system out print line print zoo inventory. That line was printed right here, printing zoo inventory. Then because it continued with the main thread, that was end, right? That was right here. Then it counted to 3, or it was counting to 3 in the meantime, and then at that point it print done. And then it had this thread in, printing zoo inventory, and it actually finished doing that. Okay? Then, and it finished doing that. Now, after all of this was done, if the service was not null, then it shut down the service. Now, interesting things to note here are the following. This printed begin, end, and then finally shut down the service. That is the main thread. So what happens is, say for example, I call shutdown if shutdown had arrived before this thread had been executed. Well, here's the thing. When an executor service is shut down, when the call to shut down starts, here's what happens. You can't do, say for example, if I am executing this one and then I'm executing this one and I call shutdown, the executor service will finish executing this one and will not accept any other tasks. So this line would have no effect, right? Would have no effect whatsoever. Now what happens with this one is so fast that all 3 go in before the service shut down. But it could be the case, like if this count is long, it might be the case that this line never executes. So the shutdown doesn't mean that the executor service is finished. It means that a shutdown signal was sent to it to say, hey, whatever you're doing, finish that and then stop. And then the keyword there is terminate. Okay? So usually you can query a thread and you can ask whether it has been shut down, meaning I said to the service, hey, once you're done, stop. Or whether it's terminated, which means, are you done doing everything? And this is how we would say, for example, if I wanted to print it out, I can print out service that is shut down. That will tell me if the shutdown signal was sent. And then service is terminated will tell me whether the service actually finished at the time of execution of this in this thread. So we can run now this. Compile and run. And here's what happens. Begin, printing zoo inventory, and whoops, and then here, it's still working here, right? It called the shutdown signal, right? The shutdown is true, but it was still doing so. It had finished doing the done. It just took long to print, right? But the shutdown signal was sent right here. Then here, is shut down, this one here, is shut down, says true. But is terminated, well, no, it's still executing stuff. So is terminated is false at this point. And then it finished executing the other 2 threads. So basically, that's the life cycle of a thread executor, a service executor service. Now, let's do a few more interesting things. So I'm going to create a little variable here, and I'm going to make it static just for simplicity. I personally not a big fan of static variables, but here they are. Okay, public static count, it's an integer. All right, and then here I'm going to have a little method, public static void add and report. And what add and report is going to do is just basically going to add to the counter, to the count plus plus, right? And then print out the value. And I can do all that in one line, system.out.println. Count is, and then plus count. Okay. All right. So here is an add and report method. And I can add more, I could have more executor service. I could say service.execute, open, close. This is the lambda notation. And then I can say add and report, right? I can do that. I can compile this and execute. And we'll see that, count is 1 is right there, right? Now, these executor services, right? Here it is, right? So they execute and they sequentially execute these threads. Now, what happens if I want to execute all these threads at the same time? That's called pooling, because the CPU will assign a slice of time to each one of these. But for that, I cannot call the execute method, and I cannot have a single thread executor, okay? I need a different structure. For that, I will need a pooling thread executor. I will need, in particular, I will need, for example, a new fixed thread pool. So let's try that. So let's do a new fixed thread pool. All these methods, all these kinds of executor services, you can find them on the API. There's a lot of them. And they offer different capabilities. One can be scheduled, for example, and you can schedule a thread to execute, 3 seconds in the future or an hour in the future. You can schedule one to be executed every hour, right? Every hour execute the different tasks. They're very powerful. But here, for example, we have a new thread pool. And this thread pool is going to be a thread pool of, I don't know, let's say 10 threads. So what this does is it creates a service that can take up to 10 simultaneous threads. If you put more than 10, let's say if you put 11, well, as soon as threads are being finished, that space is occupied by the next thread or the next task, okay? Now, I don't want to create 10 lines of this, so I'm just going to do, in here, I'm just going to do a little for loop. For I equals, for int I equals 0, I less than 10, I plus plus. And then what I'm going to do here is I'm going to say service. And here's what I do when I have a thread pool. I can do service.submit. Service.submit, and here's the service, right? So I do this, and I say add and report. So I submit the services, and they will be executed when they can be executed. So let's try and run this guy. Remember what I'm doing? I have a service, and now it's a fixed thread pool. So it's a pool of threads. It's not just one at a time. It's 10 at a time at this point. And what I'm going to do is I'm going to assign 10 tasks to it. It's the same task, right? So add and report. So let's compile and run. Execute. Now, here we have it, right? So, well, it's begin and true false. Now here the thread pool is full. So when shutdown happens, the 10 threads that are there will finish executing. It won't accept more than 10 after shutdown signal is sent. But let's look at the thread. So it increment the first count, the second, it keeps incrementing count, but printing is a very slow process. So in that thread, for example, count is 10 was printed first, right? That was the CPU somehow assigned more time to that one, and that finished first, and then 7, and then count is 1, then 8, then 6, and so on and so forth, right? Then 9, 2, 5, 4, and 3. So this is, for example, a thread executor. Let's run it again, see if we see something interesting. All right, so here we see, for example, in this run, we see that it said count is 2 twice. Well, what happens is the thread was too fast. And while this count was incrementing by one of the threads, the other thread already read this variable and it was still 2, right? That's the problem that can happen when you have many threads that access the same variables. And that is the main problem of concurrency, right? So this is a little parenthesis in ExecutorServices, but it can happen with any thread. When many threads access the same variable, you can end up with situations where two threads read the variable and they read the wrong value, because the idea here is that every thread increments the value. But in this case, twice it was read and it was the same value, so the increment was lost. And this, as you can see, the count never got to 10, it only got to 9, because two of these threads did the same thing, right? Now, that is a problem with concurrency. We're gonna solve that problem later on by synchronizing methods. So for example, if I say public static synchronized, okay, if I say that, this method immediately can only be accessed by one thread at a time, and it'll solve that problem, right? So synchronize is a keyword that can be used in Java to reduce these concurrency problems. In addition, to reduce concurrency, instead of having this variable be an int, there are some object types like integer, right? But there are some object types that are thread safe wrappers around data types. So there's a thread safe or concurrency safe, right? Integer, doubles, and so on and so forth. I'll leave those to you to experiment, right? But synchronized works fine. A couple more things in executors, right? So I'm going to go to my my single thread executor, new single thread executor. I'm going to go to my single thread executor again. I'm just for what I'm going to illustrate. There is another thing that we can do with thread executors. We can, for example, okay, here's what we've been doing. We've been sending threads, we've been sending processes to be executed, but we're not using the results of those processes. Well, what if I want a process to do something and I want the result of that process? So let's assume we have a very simple process that will return an integer, okay? And that will be like this. So service.submit. You can submit also to single thread executors. And the process in there that I'm going to submit is going to be 31 plus 10. That returns that, right? I can actually write the return statement as well. I can say return 31 plus 10, semicolon, boom, right? That I can do that, this little process. It's whatever, imagine something's happening here and an integer is returned at the end, right? I can do this, but I cannot use this result. So if I just do compile and I execute, nothing happens, right? Because I'm not using that result. Instead, but let's say I want to use this result. Well, what we need to do here to use that result is use an object that's called future. Future is a kind of object that if you declare a variable of type future, basically will have a task, right? That will execute at some point in the future. The CPU will decide when, but it's going to be very quick though. So you can have a future, and this future will return an integer. So you have a generic integer there. and then let's call result. So result is going to be service.submit this. And with result, I can do a lot of things. I can I can use that result later. So I can use system, for example, .out.println, okay? And then result.get. That will actually print the result that's coming from here. Now, when I'm running threads, there are a lot of things that can go wrong, okay? There are a lot of exceptions. Mainly there's a lot of exceptions that can go wrong, okay, that I will have to account for. So if I try to compile this, I will get, the error because I'm not throwing those exceptions, right? So interrupted exception. What happens is if the thread is interrupted, right? So I'm going to do a little catch block here. Catch interrupted exception E. I'm just adding the catch blocks for the futures, right? And then this is going to go e.print stack trace, just to do something there. Whoops. And then you will see that I also need another catch for yet another thread related exception, which is the execution exception. So I will add that catch execution exception E, and I'm also going to do e.print stack trace. These are just simple blanket statements just to catch the exception, because what I'm really interested in you seeing is that with this result, I can actually get the result of that thread. So I'm going to compile this and run it. Whoops. Execution exception. I think that's misspelled. Okay. All right. And then I run it. When I execute it, you will see 41 printed because, see, 41 right there. So the thread executed 41. So this thread, this task returned 41. So there was a thread that ran here and produced a value 41. And then I could use it in my main thread right here. And that is also a really cool aspect of service executors. I can also get, say for example, if my thread is trying to connect to the internet, I can say result.get and I can give it a timeout. So after a certain time, if it doesn't finish, it will time out. And also, if my service does not return anything, but I want to use the option of a timeout and whatnot, this generic becomes a question mark. And then the service doesn't have to return anything, but I can still use the get and then with parameters to get the results, to force it to execute and get the result in a certain timeout or with a certain frequency and so on and so forth. So I hope this gives you a good introduction to ExecutorServices, which are a more powerful way and simpler way to run threads in Java. Goodbye.